All right, let's jump right in. If you're writing Java, you're constantly dealing with groups of objects. But here's the question. Are you using the best tool for the job? Today, we're cracking open the Java Collections framework. Think of it as an essential toolkit that's going to make your code way faster and a whole lot smarter. So be honest. Are you still reaching for a basic array to handle all your data? That's kind of like trying to use the same cardboard box for everything. Yeah, it might work for a minute, but it's rigid, it's clumsy, and once you fill it up, well, you're stuck. There is a much, much better way. And you can really see the difference when you put them side by side. You know, arrays are stuck with a fixed size, right? But collections, they're totally dynamic. They grow and shrink exactly when you need them to. Plus, instead of you having to do everything manually, they come loaded with powerful built-in methods for stuff like sorting and searching. It saves you from writing all that extra boring code yourself. Okay, so let's think of the collections framework as our own personal developer toolkit. Inside, we've got 3 main families of tools, and each one is designed for a very specific job. Let's pull them out, put them on the workbench, and see what they're all about. And here they are, the big 3. First, you've got a list. That's your ordered notebook. It keeps everything in the exact sequence you put it in, and it's totally cool with duplicates. Then there's a set. Think of it as an exclusive club. Every single item has to be unique, no plus ones. And finally, a map. That's your dictionary. It's perfect for pairing a key with a value, like a word and its definition. Seriously, burn these 3 analogies into your brain. They are the key to understanding all of this. So let's grab that first tool from our kit, the list. This is your go-to anytime the order of your items really matters. You know, like a to-do list, or the steps in a recipe, or a playlist. The sequence is everything. The most common type of list you're going to run into is the array list. And the best way to picture it is like a magic notebook. You start writing down your items, and just when you think you're going to run out of space, poof, the notebook just magically adds more pages for you. It's super efficient for most of your day-to-day coding tasks. So when do you actually reach for an array list? Well, here's the simple rule of thumb. Use it when you need to grab items by their position, their index. Because it's basically an array under the hood, that kind of access is lightning fast. It's also your best bet when you're not planning on adding or removing a bunch of items from the middle of the list. But what if you do need to mess with the middle of the list a lot? Well, for that, meet the linked list. Now, instead of one big notebook, a linked list is more like a chain. Each individual link in the chain holds your data, but it also holds a little pointer that says, hey, the next item is over there. And that chain structure is what makes linked list the absolute king of modifications. If you need to add or remove items from the beginning or the middle all the time, this is your guy. Why? Well, because all you're doing is changing a couple of those little pointers. You're not having to shift every single item that comes after it, which is a huge performance win. Okay, so you've got 2 fantastic options for lists. So how in the world do you choose? Well, it all comes down to one thing: understanding the performance trade-offs for whatever it is you're trying to do. And here is that trade-off crystal clear. Need to grab an item by its index, say item number 500? ArrayList is instant, lightning fast. A linked list, though, it has to walk the entire chain from the very beginning, so it's super slow. But watch what happens when we add a new item to the front of the list. The roles completely flip. Linked list is instant because it just repoints the first link, but the array list has to slowly and painfully shift every single element down by 1. So the takeaway is simple. Pick array list for fast access and pick linked list for fast insertions and deletions, especially near the start. All right, let's put down the lists and grab our next tool, sets. The main job of a set is incredibly simple, but also incredibly powerful. It guarantees that every single thing inside it is unique. No duplicates, ever. The most popular set by far is the HashSet. And remember that analogy? It's like the bouncer at a super exclusive club. It checks every single item that tries to get in. And if someone with the same name is already on the list, nope, you're not getting in. It's all about that uniqueness. Let's see it in action. Say we have a set of colors. We add red. Cool. We add blue, no problem. Then we try to add red again. Now, if this were a list, it would be fine. But this is a set, our exclusive club. So, what do you think the final size of our set is going to be? 2. That's it. The hash set just flat out ignored the second red because it was already inside. That is its one and only job, to enforce uniqueness. And it does it for you automatically, with 0 extra work. It's awesome. And just like with lists, you've got a choice. The big question is, do you need your unique items to be sorted? If the order doesn't matter at all, and you just want super fast, unique storage, then HashSet is your best friend. But if you need those unique items to be kept in a specific order, say alphabetically, then you'll want to use a tree set instead. And now for our final and maybe most powerful tool, the map. This is what you use when you need to connect one piece of data to another. It's your digital dictionary, your address book, your phone book. A hash map is where you store things in key value pairs. And the phone book analogy is perfect. You look up a person's name, that's the unique key, to get their phone number, that's the value. This lets you do incredibly fast lookups because you don't have to scan through a whole list of people. You just go directly to the name, the key that you need. And you guessed it, just like with our other collections, we've got a choice to make, and it all comes down to order. Do you need the absolute fastest possible lookups and you couldn't care less about the order of the keys? HashMap is your champion, all day. But if you need to keep your entries sorted by their key, like, say, a list of user IDs that you want to process and order, then a tree map is the perfect tool for that job. Whew! Okay, we have covered a lot of ground. So let's bring it all together into a quick and dirty guide. How do you actually choose the right collection when you're staring at your code? It's actually a lot simpler than you think. Look, it really just boils down to asking yourself 3 simple questions. First, do I just need a simple ordered list of stuff? If the answer is yes, you're looking at either an array list or a linked list. Second, is it absolutely critical that every item is unique? If yes, then your choice is between a hash set and a tree set. And finally, do I need to look stuff up using a unique key? If that's what you need, you're grabbing a hash map or a tree map. That's it. It really is that simple. Now, this table might look a little scary with all that big O stuff, but let's just decode it real quick. O of 1 just means constant time. It's basically instant, and it doesn't matter how big the collection gets. That's the magic behind looking something up in a hash map. O of n means performance gets worse as the collection gets bigger. Think about trying to find an item in an array list without knowing its index. You might have to check every single item. And O of log n, that's the sweet spot for sorted data. It's ridiculously efficient and barely slows down even with millions of items. This table is the why behind every choice we just talked about. So you see, picking the right collection isn't just some boring academic thing. It's the real-world difference between code that is fast, clean, and a joy to maintain, and code that's a slow, buggy mess. By moving beyond that one-size-fits-all array, you unlock the ability to build smarter, more elegant, and more efficient software. So the only question left is, what are you going to build with it? That's all for this explainer.